Today's topic of discussion is the normal force. And while example 5.4 certainly is not a difficult example to work through, the reasoning behind it is absolutely crucial for some of the things that we're going to be doing a little bit later on. So I want to go through the reasoning to make sure you understand where this is coming from. In example 5.4, we have a 75 kilogram man standing on a level floor. Okay, so here's my man, and he is standing on a level floor. So it's supposed to have any sort of angle to it. We can give him some arms so that he's got looks a little bit more normal there. Okay, we know that his mass is 75 kilograms. Okay, now we also know that because he's on the earth, we know that he is being acted upon by gravity. Gravity is pulling him down. He's standing on the floor. He's not floating up around the room, right? Okay, so we know gravity is acting on him as gravity acts on anything that's within its range of influence. However, is this man accelerating? No, he's standing still. So therefore, there has to be some other force that's acting on him besides gravity, because if this is the only force acting on him, he should be accelerating downward, but he's not. So if he is standing still, that means that the sum of all the forces acting on him must be zero. That's what Newton's second law tells us. If there's a force acting down, but there's no motion, then there must be an equivalent force acting up, and it has to be the same magnitude so that the two forces are going to cancel each other out. And that force is called the normal force. I don't know why they call it that, but that's what it is called. And so the normal force is equal in magnitude, but it is opposite in direction from the gravitational force, assuming that you're on a level surface. Now, if the surface is slanted, the normal force is always perpendicular to the surface. And again, that's a topic that we're going to hit quite a bit more in Module 6. Everything that we talk about in this particular module, we're going to be talking about level surfaces. And so if your surface is level, the gravitational force and the normal force are going to be directly opposite in direction from each other. Just don't get too married to that idea, because that's going to change when we get into the next module and we're talking about inclined surfaces and ramps and things like that. Okay, so the normal force is perpendicular to the surface. Since this is a level surface, it's opposite in direction from the gravity. So if I want to know the amount of the normal force on this man, all I have to do is figure out what his weight is. Well, I know that weight equals mass times gravity, and as far as the magnitude goes, that's going to be equal in magnitude to the normal force, which I'm going to designate by an F with a subscript of a capital N. Okay, so if the weight is the mass times the gravity, I've got 75 kilograms. I'm in the metric system, so I'm going to use 9.8 meters per second squared. And I know that that's going to be equivalent to the normal force. So the weight, when I do multiply that out, is going to give me 740 newtons. And that force is going to be down. So that means that the normal force then is going to be 740 newtons up. Okay? Equal in magnitude on a level surface, they're opposite in direction. Okay? So that is your normal force.